Hello students, today we will be going over 7.5. This is page 129 in your yellow packet. Our objective, I can solve absolute value equations and inequalities, and we're going to focus on inequalities. Our instructions are solve, graph, combine, give interval, okay? And then identify the type of graph. And I actually think it's better to identify your type of graph in the very beginning. So if we have x is greater than 3, if it's greater than, it's going to be an OR graph. OR graphs are, in general, graph like this. They're going to be on the outsides. And graphs, in general, are going to be like this when they're in absolute value. So when you're graphing absolute values, you take it directly out of it, and we can say x is greater than 3. So if we go to the number line, we can go x is greater than 3. Open dot at 3, shaded to the right. Okay. So then we know that inside here can be a negative x. So if I say negative x is greater than 3, I have to solve for x. So I divide by negative 1. When you divide by a negative 1, that flips the sign. So x becomes less than negative 3. Open dot. Because again, this is less than. It's not equal to with more ink, so it's less ink. It's an open circle. Now we combine the two, and we get x is less than negative 3, or x is greater than 3. And so our interval becomes from negative infinity to negative 3, doesn't include 3, union doesn't include, or negative 3. It didn't include negative 3, and it won't include 3, comma, infinity. Okay. All right, and we're done with that problem. Okay, let's go on to number 2. Okay, we have absolute value of x is less than 1. So first we're going to identify the type of graph. All right, if it's less than, which one is it going to be? That's correct. It's and. So we're going to have an and one. I'm going to write and. Okay, so we're going to write x is less than 1. Again, you take it out till it looks exactly like the inequality, but without absolute value. So if it's less than 1, I'm going to put an open dot at 1. Shaded to the left. And what I might want to do is put a 1 there. Now I say they can also be negative x is less than 1, but I divide by negative 1. And when you divide by a negative, you flip the sign. Or x is greater than negative 1. Now, since we know it's an and, we go ahead and we shade what's in common in both. So we say it goes from negative 1 to positive 1 and shade it in between. Okay, now we need to write our interval, and again it's an and. So this time there's only one interval when it's an and. It does not include negative 1, and it does not include 1. And you only have one interval since they're not split. And we're done. Let's pause the video and see if you can do 3 or 4. Next, we're going to go ahead and go over the bottom of page 129. X is greater than 2. Okay. Again, we're going to say this is positive. Anytime you see this, think of positive. It could also be neutral. Let's see, positive. Is that greater than this positive? Now, are some positive numbers greater than other ones? Are they always greater, or are they never greater? Okay, so it's sometimes. And your solution down at the bottom, is it an or an and? It's going to be an or. greater than or. Okay. Now, absolute value of x is less than or equal to 1. So again, this is positive, and is positive less than or equal to positive? And again, that's sometimes. Okay. So our solution here, because it's less than, is going to be an and. Next, we go to x is less than or equal to -3, absolute value. So positive is positive less than or equal to negative? And the answer, it is never. Okay. So if it's an and you get a negative value here, then you will end up with an empty set. Last one, absolute value x greater than -1 is positive greater than negative. Oh, I should put negative. And the answer to that is always. And if it's greater than, it's an or. So that is going to end up being all real numbers. Okay. All right. Let's move on to page 130 and go ahead and do number 5 and number 6. Okay, so we have to isolate the variable, the absolute value, and it's already isolated. So if it's greater than, is that an and or an or? Okay, so we need to write our two equations. You write it exactly as it is first. Or, and again, we don't change this sign here. We only change this sign 9 to less than -9. X is greater than 1, or x is less than -17. Then we go ahead and graph that on the number line. -17, open dot. 1, is that an open or closed dot? Greater than 1. Or x is less than -17. And that's what your graph looks like. Our interval, can you guys see that okay? Our interval is going to go from -infinity with parentheses, comma -17. And we're going to unite or union that with open dot 1 to positive infinity. Okay. All right, let's go on to number 6. Right over here. All right, so again, this is going to end up, it's less than or equal to. So this is going to come out positive. Is less than or equal to a negative. And let's think about that. That is never true. So you have your graph. I would just put empty set on the graph, and the interval also empty set. And we're done. Okay. Now we're going to go on to page 131, and you can either pause the video and work on your own, or we're going to continue on. Page 131. We're going to go ahead and isolate the absolute value by adding 9 first. -10 minus 6v, and now that's the absolute value, is greater than -70. Okay. Now we're going to go ahead and solve this. Is positive, because this is going to come out positive, greater than negative? Always true. Now when it's always true, we can just shade the whole number line. Although you still want it to look like a number line. And our interval, I'm going to just put all real numbers, fancy I, or fancy R, I mean. And you're done. See, that's not so bad. Okay, now I'm going to go on to number 14. Again, I want to isolate the absolute value, so I'm going to times by 10, which will get rid of that. Whatever I do on one side of the equation, I do on the other. I end up with 3 minus 6v, absolute value, is greater than or equal to 30. Okay, so it's positive greater than or equal to 30, or another positive. So that's going to be sometimes. So we go ahead and make our two equations here. 3 minus 6v is greater than or equal to 30, or 3 minus 6v, whoops, v, I'm going to make it a capital V. No, I'll just redo it. Is less than or equal to negative 30. Running out of room there. Okay. So I'm going to erase this interval a little bit. Now I'm going to solve for v. Minus 3. Negative 6v is greater than or equal to 27. Divide by negative 6. Divide by negative 6. Now v, I divided by a negative number, so I must switch the sign. So 27 over negative 6, what does that equal? Is 3 goes into both, so that will be negative 9 halves. Now I'm going to solve this other one. I'm going to go minus 3, minus 3. Now I get negative 6v is less than or equal to negative 33. Divide by negative 6. Oh, guess what? I get to switch the sign here too. Again, it's an or. 3 will be 11 halves, and it's positive. Okay. All right, so now we have our number line, and we said it's less than negative 9 halves. Better make this bigger. Less than or equal to, if it's or equal to, it's a color dot. Or it's greater than or equal to 11 halves. And we know that 0 is somehow almost in the middle of those two. So for our interval notation, hopefully you can see that okay. Our interval notation goes from negative infinity to, I put it off the screen, to negative 9 halves. Infinity is always parentheses. It includes 9 halves, so it's a bracket. Make those sharp 90-degree angles. And we're going to unite that with 11 halves, a bracket, because it includes that, and positive infinity. And there you go. You can do the rest of this, students. You rock.